Okay, here we go. We are doing quadratic practice test number 2 just for the first half of the test. And the first part of our test will be to solve a quadratic using the square root method. And so this first problem here, we see that we have a proportion, and we know that to solve proportions, we cross multiply. And so I always start with my variables. Some people don't like see how we're using an a. Some people don't like that. You can always change that to an x if you want to change that. We'll change the a's to an x. So here we go. A times a is a squared, or you could write x squared either way. And 36 times 9, that is 324. And now we're going to go ahead, and since a is squared, to get rid of the square, we do the opposite, which is the square root. And whatever we do to one side, we do to the other side. We also learned that when we take the square root of both sides of an equation, we have to put a plus or minus in front of the number that we're taking the square root of. So the square root and the square cancel each other out, and we're left with a. And then when we put square root of 324 into our calculator and hit enter, we get 18. So our answer is plus or minus 18. That plus or minus is really important. That means that we have two answers. Either 18 will work to make this equation true, or negative 18 will work to make the equation true. Number 2, here we go. Let's make it a little bit bigger. I guess you guys can see it. So we have a couple different ways that we can do this. The first way is we could just distribute, just like we would with solving a linear equation. And I'm going to do it that way. Our other way would be we could divide both sides by -2. Maybe I'll do it both ways. So here's the first way. If I distribute, it's going to look like this, right? And then if I want to do the square root method, that means I want to get x squared by itself. So that means I want to move the -16 to both sides and end up with, let's see, -8, 128, right? And then divide both sides by -2. So I get x squared equals 64. And then the opposite of a square is a square root. And whenever I do to one side, I have to do the other. When I take the square root of both sides of an equation, I have to put the plus or minus in front of the number that I'm taking the square root of. So square root and square goes away, so I end up with x equals, if I put square root of 64 in my calculator, I get 8, and I will remember the plus or minus. Now the other way to do this problem, let me do it another way. So you have two options. And the other option is this. If I want to get the x squared alone, I could get rid of the -2 first by dividing both sides by -2. So when I divide this side by -2, it's gone. I have x squared minus 8 left. When I divide that side by -2, I get 56. And then I want to get x squared by itself, so I'll add 8 to both sides. So I'll get x squared equals 64. And then we'll do the same thing. I'll have x equals plus or minus 8. So either way, we're going to get the same answer. Okay, here I've got x plus 4, x minus 4, this whole thing is being squared. So I can go straight to getting rid of this square. So I'm going to go ahead and take the square root. See how if I take the square root of this, the square goes away to end up with x minus 4. And if I take the square root of one side, I have to take the square root of the other and put the plus or minus in front. If I put the square root of 225 in my calculator, I'm going to get 15. Now, this is strange. This is the first time we've seen this. Well, not really, but let's pretend we're just seeing this for the first time. This is the type. This is the type where we have two different answers. We have to branch off into two different equations because can you see x minus 4 can be equal to 15, or x minus 4 is going to equal -15. That's what this plus or minus really says, that we have two separate equations. Now note, we didn't have to do it before. Like, see the answer x equals plus or minus 8? We don't have to split it up into x equals 8, x equals -8, right? Because x was all by itself. We didn't have to do any splitting. But here, x isn't by itself. X has this -4. That's why we have to split it into two things, because we're not done yet. So we're going to go ahead and add 4 to both sides. So one of our answers is 19, and we add 4 to both sides. Our other answer is what? Negative 11. Those are our two answers. And let's move to the next one. So here we want to get x squared by itself. We need to get rid of the 3. So we're going to subtract the 3 from both sides. Bring down the negative 4x squared. We get negative 88. Then we're going to go ahead and divide. We're going to get rid of this negative 4 by dividing both sides by negative 4. We get 22. Okay, we want to get rid of the square, so we're going to take the square root, take the square root of both sides, put that plus or minus. When you put the square root of 22 in your calculator and you hit enter, if you're using one of the yellow calculators, you get square root of 22. And that's actually the most concise answer that you can give. That's truly the answer. If your calculator, if you're using a different calculator, it might give you x equals 4.7 something, and we could go ahead and round it. This could also be your answer, but know that the square root of 22 plus or minus the square root of 22 is the perfect answer. Okay, this next one, we want to solve using the square root method. That means we want x squared to be by itself. So we've got to move the 64 to both sides. We get x squared is equal to 64. And to get rid of the square, we're going to take the square root on both sides, of course. We put square root of 64 into the calculator, we get 8. And because it's in an equation, it's plus or minus. So note, square root of 64 really is just 8. But because it's in an equation and we're taking the square root of both sides, we put the plus or minus. And we talked about this in class. I don't need to repeat that. Yes, negative 8 squared is also 64. All right, so here, teeny tiny problem. Let me make it bigger. Okay, here we don't have a choice. I saw some people today distributing. No, we can't distribute. Why can't we distribute? Because this 2, this square, belongs to the quantity x plus 7. And so we can't break up that. That's, think about order of operations. Exponents are going to come first, parentheses and exponents. So we've got to get rid of this 2 by dividing both sides by 2. So when we do that, we end up with x plus 7 squared equals 9. And then we notice we have this whole thing squared. There's nothing more to get rid of except for the square. And the only thing that gets rid of the square is the square root. We're going to square root both sides. So when the square is gone, we end up with x plus 7 equals plus or minus 3. If we put square root of 9 in our calculator, we're going to get 3. Once again, if we didn't have the 7, we would be done, right? We'd say, oh, x equals plus or minus 3. But when x has company, that means we have to split it up into 2 equations. Either x plus 7 equals 3 or x plus 7 equals negative 3. And we'll go ahead and continue and solve. We'll subtract 7 from both sides. So we have 2 answers here. Either x is equal to negative 4 or x is equal to negative 10. And that, my dear ones, is the last one for the square root. And now we're moving on to solve using the quadratic formula. So I'm going to do this 2 ways. Just to show you. I am going to use a quadratic formula first. I'm going to say a equals 3, b equals negative 18. Oh my gosh, there's no c. That means c is 0. And then I'm going to sing my song. Yes, you know the one. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right. And then I would plug in. I'm going to go ahead and do this. And it's a big mess, but at least it will give us the answer, right? If I continue on this route, 2 times 3. If I continue on this route, what I will get is, let's see, what will I get? I'll get x equals, now negative 18 is going to give me positive 18. And this is going to give me plus or minus 18 all over 6, right? Put that in my calculator. Right at this part right here, when we put that in our calculator, that when we hit enter, equals 18, so that's why I rewrote that. Then I'm going to split it into two possible things. Either x is 18 plus 18 divided by 6, or x is 18 minus 18 divided by 6. So in the first case, we're going to get what? 36 divided by 6, which is 6. In the second case, we'll get 0 divided by 6, which is 0. Now, because it says solve by using the quadratic formula, that's what we did. But if you are clever enough to notice that anything in this section can be factored, then I'm allowing you to factor it. There are going to be some, just like in this section on the test, that are not factorable, and that's when we use the quadratic. That's when we use the quadratic formula. We talked about this, the reason why I'm allowing this in class, so I don't really need to go over it, but basically that's how you're going to be treating the quadratic formula from here on out. In Algebra 2 Trig, in pre-calc, and in calculus, if you ever need it, you're going to go for factoring first. So that's what I want you to do on this test. If you can't factor, then you've got the quadratic formula, and later on you'll learn completing the square. All right, so I'm going to redo this, the same problem, but I'm going to say, hey, what goes into both 3a squared and negative 18a? Well, I know my greatest common factor of 3 and 18 is going to be a 3, and with a squared and a is going to be an a. So I factor out of 3a. And what's great about factoring is, now once again, notice if I were to distribute, I'd be back to where I started from. So factoring is undistributing. And so the reason why I distribute is because I have something times something equals 0, which is great because then I know, hey, either 3a is the one that is equal to 0 or a minus 6 is the one that's equal to 0. And if I solve this, I get a equals 0. And if I solve this, I get a equals 6. Same answers, just a lot faster. So if you are clever enough on the test to notice that you can factor, I will still give you credit because there are 2, 3 problems or so where you can't factor, and you're going to have to show me that you know how to use quadratic formula. Okay, so number 8, this is a big mess, so let's get everything on the left side. I'm going to add the 3. I'm going to add the 5x squared. And let's see what I have. I have, what, x squared minus 8x equals 0. Okay, so with this, something happened here. Let's see, what did I do wrong? This doesn't even look like the number 8 on the, hold on just a second. Okay, yes it is. Okay, I'm good. I'm going to factor, guys, because I can see that x goes with both of these. And I can factor out an x, and then I have something times something equals 0. So the multiplicative property of 0 says either x is equal to 0 or x minus 8 is equal to 0. So that means my answers are 0 and 8. If you want to use the quadratic formula for this, you are welcome to. We would start from here, and if you wanted to use quadratic formula, we would have said a equals 1, b equals negative 8, and there's no c, so when there's not a c, it's 0, and you would have set it up that way. Okay. And you would have gotten the same answer, 0 and 8. So let's look at number 9. I'm looking at number 9. I want to make sure that I'm also looking at my key because I can't sometimes do all these things in my head. So let's see, we're going to go ahead and subtract the 1 from both sides and add the x to both sides. So we'll end up with negative 9x squared plus 36x minus 31 equals 0. Oh, this is a real bummer. We can't do anything with this problem as far as factoring. Is there a number that goes into negative 9, 36, and negative 31? No, it doesn't help that 31 is a prime number, right? So we don't have a choice. We are going to use quadratic formula. Here we go. A equals negative 9, b equals 36, c equals negative 31. I'm going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and then just like in class, I know I'm going fast. Please pause me if you need to. So this is what we focus on first. We're going to put that into our calculators, and we will find that that gives us, all right, let's see, which one am I on? Sorry, I keep picking up practice test 1, and I'm like, that's not the answer. Okay, so we're looking at this, and this is going to give me, it looks like in my practice test thing, I rounded this to 13.4. It probably did give me a messy square root, but I'm hooked up to a mic, and I can't find a calculator. So this is the way we're going to do this one. If it was a messy square root, we could just leave it as such. So let's see, we're going to have x equals negative 36 plus or minus 13.4 all over negative 18. And then we'll split that up. We're going to use the plus for the first one. When I put that into the calculator, that gives me 1.25. So that's one of my answers. And then the other possibility is if we use the minus 13.4. And if I put that into my calculator, thank goodness, I already have done this, it gives me 2.74. All right, let's look at 10. It is a proportion. We're going to cross multiply where we want to multiply the terms with the variable in first. So when I cross multiply that, it's saying 4v times v minus 3. Once again, feel free to change out your v's for x's if you like x's better. It's the same thing, they just represent an unknown, right? And so when I have this, I know that I need to distribute. So 4v times v is 4v squared, and 4v times negative 3 is negative 12v. And what else do I need to do? I need to add 35 to both sides. Note that there's not another number to add 35 to, so it just goes along for the ride, getting tacked on to the end. Nope, there's not, unfortunately, a number that goes into 4, 12, and 35. Nope, so we are forced to use quadratic formula. Okay, let's switch colors here. Got a lot of green going on. X equals negative b. All right, since b is negative anyways, it's going to be negative 12, which is positive. Plus or minus square root b squared minus 4ac all over 2a. All right, so this is fun. Once again, please pause me if I'm going too fast. Trying to make the video short, but if you need more time, please pause. When I put this into my calculator, and go ahead and pause me and see what happens when you put into your calculator, but when I do, I end up with error, right? Don't I end up with, what does it say, domain error? And that means basically that I end up with a negative number underneath my square root sign, and I can't take the square root of a negative number. And so when I get domain error, I stop and say, no solution. And this just means that our parabola, or the graph of our quadratic, is not touching or passing through the x-axis. Remember we talked about the floor, the x-axis being 0. So it just doesn't have any zeros. All right, you just write no solution. And we're into our last section, solve by factoring, which we already did some solving by factoring, didn't we? With factoring, we want everything on the left side. We cannot factor until we have a 0 on one of our sides. I just say bring everything to the left just because I like things on the left. So what do I have? I have x squared minus 7x minus 18. And because we got rid of the 7x and the 18, there's 0. We cannot start factoring unless we have a 0 on one of our sides. Okay, when I have a trinomial, a polynomial with 3 terms, I set up my parentheses, and I still am undistributing. I know that if I have an x squared, I'm going to put my x here, and it feels like, whoa, we're almost done. We need to come up with two numbers. These two numbers have to multiply to equal negative 18, but they have to add up to equal negative 7. So we're going to go through some options. I think about 3 and 6. Well, 3 times 6 is a positive 18. So I know instead one of them need to be negative. So it's either negative 3 times 6 or 3 times negative 6. Let's stop and see. Will negative 3 plus 6 or 3 plus negative 6 add up to negative 7? No. Okay, let's move on. How about 2 and 9? Either negative 2 times 9 or 2 times negative 9, both will give me negative 18. Will either one of them give me negative 7 when I add them together? Yes, 2 and negative 9. Both multiply to equal negative 18 and add to equal negative 7. So we'll come back here and we'll use a plus 2 and a minus 9. And voila, now we have something times something equal to 0. And that's a wonderful place to be in because we can split it up into two equations using the multiplicative property of 0. So here we go. We're going to subtract both sides by 2. And there's one of our answers. We'll add both sides, 9 to both sides. There's our other answer. And those are the two places that this quadratic, when we graph it, will pass through the x-axis. But you don't need to think about that right now because we're not there yet. But those are our two answers for this equation. Okay, with 12, we've got a proportion again, and we know that with proportion, we're going to go ahead and cross multiply, doing the side with the variable first. So I'll have x times x minus 10. Then I'll do the other side. Okay. Now this is interesting because we do have something times something, but it's not equal to 0. So we can't jump to, I can't say x equals negative 25 and x minus 10 equals negative 25. No, 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 I can't do that. It has to be a 0 on the other side, which means that we don't have a choice. We're going to have to distribute. And then, of course, we're going to want to bring the 25 over. There's not another number to add it to, so it's just going to tag along at the very end, just like that. Now we're looking for two numbers. Let's see, we're going to set up, because we have a trinomial, we're going to set this up. Now we're looking for two numbers that multiply together to equal positive 25, and then add together to give me a negative 10. Well, two numbers pretty much pop in my head. How about yours? How about negative 5 and negative 5, right? Negative 5 times negative 5 gives me 25, and negative 5 plus negative 5 gives me a negative 10. So we're going to use that. And even though we're going to set up two problems here, we actually only have one answer, right? And that is x equals 5, which means if we were to graph this quadratic, it would only touch the x-axis in one place, where x is equal to 5. But we're not there yet. So just know that this equation, if you plug 5 in for x, it will make this equation true. Okay. Now, just like with the other, if you can think of a better way to solve this than what I'm going to do next, then you can. Can we solve this using the square root method? Absolutely. If you are clever enough during the test to find an easier way to solve than the way they're asking you to solve, then that is fine with me. Right now I'm going to factor though. We talked about the difference of two squares. If I have an x squared and a minus sign and a 49, x squared and 49 are both perfect squares. And when we see this, we can factor like this. X plus 7, x minus 7. If we spent the time to do the distributive property, we'd be right back where we started, x squared minus 49. And then we have something times something equals 0. So we set them up both equal to 0. X equals negative 7 and x equals positive 7. That's one way to solve it. I think that if your brain looks at this and goes, oh man, I can solve it faster using the square root method, I want to let your brain work. I want your brain to do some things that make sense to it. And we get the same answer. That's the cool thing about math, isn't it? So many times there's more than one way to do something. All right, so let's look at 14. We're looking for two numbers that multiply to equal 6 and add to equal 7. Well, I think about 2 and 3, right? 2 times 3 is 6, but unfortunately, 2 plus 3 is 5, so that's not going to work. How about the only other option we have is 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. So let's use 6 and 1. Now, if we spent the time to do distributive property to what we just wrote, we would end up back with x squared plus 7x plus 6. So we are really, when we factor, we're just rewriting what we have in a different form so we can use it to solve our problem. And so we have something times something equals 0. So either x plus 6 equals 0 or x plus 1 equals 0. So we end up with either x is negative 6 or x is negative 1. Okay, number 15. I believe that we solved one like this in the quadratic one. Sometimes factoring is not going to look like when we factor a trinomial, right? When we just have a binomial, factoring is going to look different. And so with that, we're looking for our greatest common factor. Remember that from middle school? Saying, is there anything in common with x squared and with negative 8x? And we can see that they both have an x in them. Okay. So when we distribute, we use multiplication. When we undistribute, when we factor, we use division. X squared divided by x is x. Negative 8x divided by x is negative 8. If that didn't make sense to you, you just want to make sure you can put the numbers or the term in that needs to go in place so that when you do distributive property, you end up back where you started. X times x is x squared. X times negative 8 is negative 8x. All right, why did we factor? Because now we have something times something equals 0. So either x equals 0 or x minus 8 equals 0. So we have two answers. Either x is 0 or x is 8. Both of those will work to make that equation true. I believe this is our last one. Yay! Okay. If we notice the past few trinomials that we have, let's see if we can find them. Okay, there's a trinomial. See how I didn't have a number? I didn't have a coefficient in front of my x squared? Actually, I did. It's a 1, but that doesn't show up. Same thing here, no coefficient. If you could look right here, I just had x squared. So all my trinomials before I factored them all had a 1 in front of the x squared, that was unseen. But now we are seeing that we have that too. And that's not good because it's going to make factoring a lot more difficult unless we can get rid of it. So can we get rid of it? Yes, we can. What does 2, negative 16, and 24 have in common? What's their GCF, their greatest common factor? Yes, that's right, it's 2. And so we can divide through by 2 as long as we do it to every term on both sides of the equation. So 2 divided by 2 is equal to 1. We don't write that 1 anymore. It's just we know that there's a 1 there. We just don't write it. Negative 16 divided by 2 is negative 8. And 24 divided by 2 is 12. And 0 divided by 2 is 0. Okay, let's come up with two numbers that when multiplied together equal 12, but added together equal negative 8. Ooh, that told me right away because of this negative 8. That when I'm using numbers like 3 times 4, sure, 3 times 4 is a positive 12, but when you add them together, they're going to be a positive number, not a negative. So what if we looked at negative 3, negative 4? Well, let's see. Negative 3 times negative 4 is positive 12, but negative 3 plus negative 4, while it is a negative number, it's negative 7. Not quite. Let's try 2 and 6. Negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. Yay, they're the winners. Let's put them in our factoring parentheses. We're undistributing. And now, wonderful news. Something times something equals 0, which means that either this something equals 0 or this something equals 0, which means that x can be either a 2 and make that equation work, or x can be a 6 and make that equation work. You've got two answers. Hope you enjoyed this. Please, if you still have questions after this practice test 2, look back at your notes. Our test is Friday. Study. Good luck. I'll see you in class.